Okay, this is M1 paper, October 2022, question 8. It's the last question of October 2022. As we can see, it's a vectors question. Let's have a read through and get started with it. So it says, two ships A and B are moving with constant velocities. Ship A is 3i plus 12j velocity. Ship B is pi plus qj. Find the speed of A. Well, that's dead straightforward. Normally I draw a little diagram out. I don't even need to with this, but this, I quickly looked over. It's only worth 2 marks here. This is a gimme, really, that's for part A. If they tell you the velocity of anything, which in this case they've told us is 3i plus 12j, and they then want the speed is just the magnitude of the velocity. So it's just going to be the square root of 3 squared plus 12 squared, which is square root of 153. You can leave it however you want. You can put it as 3 root 17. You can put it as some sort of decimal if you want. Kilometers per hour. So nice little gimme for 2 marks there. Let's go on and look at the rest of the question. Ships are modelled as particles. At 12 noon, A is at that position, minus 9i plus 6j. B is a different place, 16i plus 6j, and then it goes on to ask me something else. Now, from my experience with vectors, and obviously being the last question on the paper, if you've got a little bit of time, what I always do is draw a quick sketch out, just to sort of, and it's a sketch, it doesn't need to be perfect, but just to see what's going on here. So in this particular question, they're saying that A is at minus 9i plus 6j, and it's got a velocity of sort of 3i plus 12j. And B, so that's where A generally will be, and B starts off at 16i plus 6j. So again, even though this is a sketch, if it's 16i and 6j, it's on the same vertical, the same horizontal, so I'm going to put B as 16.6 here, and then PQ. Well, if they're likely to meet then, or be getting close to each other, I'm going to put PI plus QJ there. It doesn't matter if I'm wrong, okay? The maths will tell me later on what's going on, but that just gives me an understanding of what's happening in the question. Now, I've done this question already, and that makes no difference at all this time. But if I'm modelling how I would normally approach one of these questions, this is normally what I do to see, are they going to meet up here and what else is going to go on? So I think sometimes it's quite useful if we have questions that involve it being due east of it or the closest distance, whatever, just having an idea what's going on. Anyway, let's crack on with this question because I'm taking too long. So it says, let's go back to it. At time t hours afternoon, AB is equal to 25 minus 12t I minus 9tj. So AB is going to be whatever that vector there is. It will change all the time as A and B move. But AB I can get then if I do, let's just clear this up a little bit. If I use our standard R equals R0 plus VT, vector equation of a line, quick reminder, that's the point that it starts off from, and that's the velocity that it's going with then. I can quite quickly get an expression for RA. So RA, where does it start off from? And this is sort of where that diagram's helping me a little bit. Plus 3i plus 12j t. And what it definitely sometimes helps me with is to now make sure that that one and that one are that one and that one there. I make so many mistakes when I'm doing these questions with mixing up everything because I don't concentrate when I'm doing the questions. RB then is same thing but the other side. So it's 16 and 6 is where it starts off from, and PI plus QJ is the velocity, the thing that I'm multiplying by t. So now AB. AB is always, I'm not explaining this to you, go away and do a little bit more work on this if you need to with this. AB is always going to be RB minus RA like that. You've got to go away and make sure you're happy with that, otherwise you're going to struggle with any of your vectors questions. So in this case, AB is going to be this one, take away this one. I'm going to do it really slowly just because I don't want to make any mistakes. Okay. I'll map it on the video here. He says, as he puts this out the eye, 16i plus 6j plus t lots of pi plus qj minus, and this is a place where I might make a mistake here, so when I'm doing minus 9i plus 6j, which is the first bit, but it's minus all of it, that bit there, up and that's got to be a minus as well there. So I'm sort of trying to predict where I might make a mistake and then just being careful with it. Doesn't stop me from copying a 3 as a 2 or something like that, but the predictable mistakes we need to see if we can try and eliminate as we're going through. But I need to concentrate here, otherwise I will make a mistake. I'm going to collect all my i's together. So if I collect my i's together, I've got 16, I've got pt, I've got 9, and I've got minus 3t. That's all the i's combined. And then with the j's, similar thing. I've got 6 qt minus 6 and minus 12t. Lots of j there. Do this yourself and then match it up to my one. Tidying that up then, I've got 25 plus p minus 3t. That's what I've got for the I. And I've got, just q minus 12 for the j. I suppose that could come outside the thing. Doesn't really matter. Don't need to double bracket there, do I? And now what I can do is make the comparison with what they told me that AEB was. They told me in the question that AEB was 25 minus 12ti minus 9tj. Oh, brilliant. That means I can work out P and Q. Really straightforward. What have I got here? I've got 25 plus p minus 3 and 25 minus 12. Well then that and that are the same as each other, aren't they? So I'm going to get p minus 3 equals minus 12. So p equals minus 9. Be careful with these silly little bits, often where we can make some mistakes if we're not being careful. And q minus 12 is equal to minus 9. So q works out to be equal to 3. So what was I trying to do? Yeah, I was trying to find the value of p and q. So we've done that part. Okay, on to the last part. The last part says, find the bearing of A from B when the ships are 15 kilometers apart. Find the bearing. Well, I know how to find the bearing. I'll do that in a minute. Once I've got A, B, I can just draw out a diagram to work out angles and bearings and anything else like that. But before that, they're telling me that it's when the ships are 15 kilometers apart. So when the length of AB is equal to 15. Okay, so if AB now is equal to 25 minus 12ti minus 9tj, and they're telling me that AB equals 15, yeah, I can work out what t is going to be for that. So if that's true, the length of AB is the square root of 25 minus, 25 minus 12t squared plus minus 9t squared. So that's equal to 15, square both sides, 25 minus 12t squared plus minus 9t squared is going to be equal to 225, let's just make that a bit clearer, is going to be equal to 225 there. Multiply it all out and tidy it up, and again you're going to need to do this yourself a bit quicker. A minus b all squared, that's going to be 144t squared minus 600t plus 625, that's just that bit, plus 81t squared is going to be equal to 225. Right, I want that to look like my normal quadratic, which will be getting everything over and equal to 0. So I get 225t squared minus 600t plus 400 equals 0. And again here, you've got to be good at doing this sort of thing. If you've experienced, you've done lots of questions, you could stick down the quadratic formula, I suppose, but they do a normal trick. So one of the things they do is this is all going to divide by 6, or all going to divide by 10, or all going to divide by whatever. Try and find the biggest number that goes in. So I know 5 goes in, 10 doesn't, 15 doesn't, 25? Yeah, I think 25 goes in. Try it, and it comes to 9t squared minus 24t plus 16 equals 0. Well, if they've gone to all the bother of making sure that that tidies up like that, pretty certain that that is actually going to factorise, okay? So again, you might have some whizzy quick way of doing it on your calculator to get the answers. I'm a bit more old-fashioned than that. I'd just factorise this. It actually factorises to 3t minus 4, 3t minus 4. So we only get one answer. We get t equals 4 over 3. So that's the time. Now, what am I doing? No, I don't want the time for anything. I want the bearing. So I've got to put that t back into AB to work out what AB is actually going to be. It's actually going to be in hours, isn't it? But it doesn't matter because I'm just putting it straight back in. So when t equals 4 over 3, just stick that back into AB, which was this bit here. So AB works out to be equal to, when you stick 4 over 3 in, it works out to be 9i minus 12j. Right, good. Finally got to that stage then. This business about the bearing should not catch you out now. Just do a quick sketch, okay? What does 9i minus 12j look like? And I just want to make sure I get it in the right direction. Is it going that way? Is it going that way? Is it going that way? Etc. Because, that will help me to work out where my angle is. So 9i minus 12j, 9i minus 12j, make it a bit longer, is going to be going in that direction there. 9i minus 12j. I can work out that angle there, can't I? Tan theta is just opposite over adjacent. Don't worry about the negative. I'm only interested in the acute angle there. Don't get confused with anything. Don't care about the signs of these things. I just want what theta is going to be. So theta works out to be equal to 37 degrees. And now go back and check, what do they want? Sometimes they might have asked what angle it makes with J, what angle it makes with I, what angle it makes with the positive x-axis. In this case, they've simply said, what bearing is it travelling on? So the bearing measured from the north in a clockwise direction, isn't it? So the final little bit, the bearing, our answer, what we require, is 90 plus 37, and that works out to be equal to 127 degrees. Not a bad vectors question to finish off this paper. I think we've had harder ones in the past, and hopefully that makes sense.